Okay, these are the systems of equations we've been given, and we're asked to solve them either by row echelon form or reduced row echelon form. I'm going to do these by hands to demonstrate for you what is going on. You are allowed to use your calculator, and I'm going to show you also how to use your calculator. So, first you would, and I will ask you to do at least this much, write down the augmented matrix. So, let's do that. The augmented matrix for this one would be 1, 2, 1, negative 5, negative 3, negative 6. So, my goal is to make this look like ones on the diagonal and zeros underneath, or ones on the diagonal and zeros everywhere. That's my goal. So, this is not a very hard system. I picked a simple one to show you kind of how it would go, but to imagine if it got more complicated, how long it might take. So, all right, ready? I want ones on the diagonal, and I want to zero out everything else. So I'm going to try to get rid of this 2. I'm going to try to kill this 2. So what I'm going to do is I'm going to multiply the top row by negative 2, and then I'm going to add it down. Now, I'm allowed to borrow the first row and multiply it and then add it down, but I don't even want to change the first row. So you don't have to do that. This is number 3. Any row may be changed by adding to its elements a multiple of the corresponding elements of another row. So I'm going to multiply this top row by negative 2 and add it down. I'm going to leave the top row like it is. So I don't really want to change the top row for the future. So this is the next iteration, what this is going to look like. I'm leaving the top row 1, 1, negative 3. But to the second one, I'm going to add to this row negative 2 multiplied by this. So 1 times negative 2 would be a negative 2. This would be a negative 2. Negative 2 times negative 3 would be a 6. So if I add down, negative 2 plus 2 is a 0. Negative 2 plus negative 5 is a negative 7. 6 plus negative 6 is a 0. This is what I have next. Now, I want zeros on the main diagonal. Ones on the main diagonal. I have a 1 there. I would like to make this a 1. The next thing I'm going to do is multiply the bottom row by negative 1 over 7. If I do that, and I'm allowed to do that because of row number 2, the second transformation is what I'm using. If I multiply this by negative 7, my top row stays the same. 1, 1, negative 3. I didn't do anything to him. Negative 1 over 7 times 0 is 0. Negative 1 over 7 times negative 7 is a 1. Negative 1 over 7 times 0 is a 0. I'm almost there. Now, if I want this to become a negative 1, a 0, I'm going to multiply the bottom row this time. I'm going to multiply the bottom row by negative 1. And I'm going to add it to the top row. And then I'm going to add it to the top row. But I'm leaving the bottom row the same. So let me just go ahead and establish that. I like the way this looks, just like this. I want that to look like that. Negative 1 times 0 is a 0. Negative 1 times 1 is a negative 1. Negative 1 times 0 is a 0. Now I'm going to add up. 0 plus 1 is a 1. Negative 1 plus 1 is a 0. 0 plus negative 3 is a negative 3. And now, this is in reduced row echelon form. X is negative 3. Y is 0. That is how you can solve that. I got that in RREF. Augmented matrix. 4, 2, 1, 1, augmented with 5, 3. All right, what I'm going to do here is I want a 1 in the first in this spot, so I'm going to multiply the first matrix through by the first row through by 1/4, and so that's going to give me 1/4 times 4 is 1. 1/4 times 1 is 1/4. 1/4 times 5 is 5/4. All right, and now. This is a 2, this is a 1, this is a 3. Now I'm going to multiply the top row by negative 2. And then I'm going to add it down. So I'm going to leave the top row the same. 1, 1/4, 5/4. I'm going to multiply this by negative 2 and then add down. So this negative 2 times 1 is a negative 2. Negative 2 times 1/4 is a negative 1/2. Negative 2 times 5/4 is a negative 5/2. And then I'm going to add down. Negative 2 plus 2 is 0. Negative 1/2 plus 1 is 1/2. Negative 5/2 plus 3 is, that's negative 2 1/2 plus 3, that's a 1/2. Now, this time I'm going to go for, I solved the first one, I got it all the way in this RREF form. I'm going to do this one, I'm just going to get it in REF. I'm going to get a 1 right there by multiplying this thing by the bottom second row by 2. So this is going to be 1, 1/4, 5/4. If I multiply this by 2, 2 times 0 is 0, 2 times 1/2 is 1, 2 times 1/2 is 1. Okay, this is not RREF, it's just REF, but it's still helpful when you're doing this stuff by hand. What did this tell me? This told me that my second variable, which is y, 0x plus 1y, is 1. And this told me that 1 times x plus 1/4 y is 5/4. Okay, that's great. Now I'm going to use substitution. I'm going to put a 1 in for y and solve for x. X plus 1/4 is 5/4. I'm going to subtract 1/4 from both sides and get x is 4/4 or 1. X is 1 and y is 1. And so I can solve that one. This one I'm going to use my calculator for because, my goodness, that takes a long time. So, write your augmented equation. It goes like this. 1, 2, 1, 1, negative 1, negative 2, negative 1, 1, 3, augmented with 6, negative 9, 1. Take note of what size this is. This is a 1, 2, 3 by 1, 2, 3, 4. It's a 3 by 4. Now, get your calculator out. What you want to turn it on. What you want to do is go to your matrix button, and that is the 4th key down on the far left. So hit the blue second button, and then matrix. And what you should see, if you've never entered in a matrix, you won't have numbers where I do, but you'll have the columns A, B, C, D, and so on. So you want to toggle over to Edit, and highlight Edit, and hit Enter. And then it should say Matrix A, and it should have a flashing cursor. That is the first dimension, the number of rows. You should enter a 3, hit Enter, and then it will go over to the next number and hit the number of columns. I want 4. And hit Enter, and then it's going to put places in there. And so I'm just going to go in and feed, I'm going to say 1, Enter, and then it'll skip to this place. I'm going to say 1, Enter, negative 1, Enter, 6, Enter, and it's going to put these in the elements. So I'm going to go through and say 1, Enter, 1, Enter, negative 1, Enter, 6, Enter, and then it skips down to the second row. I'm going to say 2, Enter, negative 1, Enter, 1, Enter, negative 9, Enter, 2, negative 1, 1, negative 9. Now I'm on the third one. 1, negative 2, 3, 1. Okay. Then to get out of this editing mode, hit second quit. Second, and the quit button's the mode button, and that gets out of it. Now, if I want to see that I entered this right, it's worth looking at. Hit second matrix, and I entered mine in A, so I hit select 1 and then enter, and it's going to display my my matrix, and I say 1, 2, 1, 1, negative 1, negative 2, negative 1, 1, 3, 6, negative 9, 1. Okay, so I checked that I entered it correctly, because if I didn't, it's all going to be wrong. So double check that. Now, how do I get this to be in reduced row echelon form? Go to second matrix, toggle to the right one so your math is highlighted. Then go all the way down to B. You have to kind of hit the down arrow. You'll pass a bunch of stuff, and A is REF, row echelon form. B is RREF. That's the one I want. So I hit Enter, and then I have to say, it gives me this, and then I have to say, okay, what element what matrix? So I'm going to say second matrix 1, which we'll put in A. Second matrix 1, like that. And then I'm going to hit Enter. And it gives me the reduced row echelon form of my matrix, just like that. And I can see that X is negative 1, Y is 23, and Z is 16, just like that. And so that is a big time saver using calculators. So that's how you do that. We're going to practice it one more time with this word problem. So this is our word problem with this one, and it goes like this. It says, 3 kinds of tea are being mixed together. This is a mixture problem. So probably you've done a mixture problem before. This is how I like to organize mixture problems. In my mind, I am always drawing a chemistry beaker. It might not look like that to you, but that's what I draw whenever I have a mixture problem like this. Like different chemicals are being mixed, or different peanuts are being mixed, or something like that. So this is teas being mixed. So 3 kinds of teas are being mixed. One worth $4.60, one worth $5.75, and one worth $6.50 per pound. And they're being mixed in order to obtain a mixture that's going to be worth $5.25 per pound. And they're going to mix up 20 pounds of this. So you can read the problem yourself, but basically it says we're mixing this type of tea and this type of tea and this type of tea in order to get our fine mixture of tea. We're going to make it green tea there. And it's going to be 20 pounds. Is how much it's going to be. And how much is the final product worth? The final product is going to be worth, they want it to sell for $5.25 cents per pound. Okay, so with a mixture problem, you always put in 2 things. One is the amount.
Sorry, I'm not sure what you mean.
Oh, Alexa's talking to me. One is going to be the amount, and the other thing you put in here is sometimes it's a percentage, and sometimes it's a price. In this case, it's a price. Okay, so what are the different values of the teas? One is worth $4.60 per pound. One is $5.75 per pound, and one is $6.50 per pound. That's the price. Now, we don't know how much. This is our variables. X represents the number of pounds of $4.60 tea we're using. Y is the number of pounds of the $5.75. And Z is the amount or the number of pounds of the $6.50 tea we mix together in order to get this. So, this is how you set it up. One equation will always come from simply adding the amounts that you have together. So, I have X amount of tea plus Y amount of tea plus Z amount of tea, and that together is going to equal to 20 pounds. That will always give you one equation. Here's where another equation will come. It's percent times amount plus percent times amount plus percent times amount equals to percent times amount, or in this case, price times amount, price times amount, price times amount. So, 460 times X is the total value that this tea is bringing, plus 575 times Y is the total value that this one's bringing, plus $6.50 times Z is going to equal to 525 times 20 pounds. That is what that's going to equal to. Okay. Now, we have to have 3 equations if we have 3 variables. And so there's an extra piece of information in here. It says that the amount of the 460 tea used is equal to the 2 other kinds together. When I read that statement, I understand that I'm using more of the $4.60 tea than I am the others, because his amount is equal to twice the others. So, how do I represent that? Is that, let's see, you are going to equal to the amount of this and this together. Is that what it says? Yeah. So X is going to equal to, the amount of this is going to equal to Y plus Z. The amount he uses is equal to those 2 together. Is that what that says? Yep, that's what that says. Okay, there's my 3 equations. So now I'm going to get this in a little bit better shape. I'm going to subtract these over here so I have all my variables on the same side. So I'm going to rearrange this. I'm going to call this X minus Y minus Z is equal to 0. I just rearranged those. That's okay. And I'm going to multiply 20 times 525. And that gives me 105. This multiplied times this is just the number 105. Now, I'm going to write this in an augmented matrix. Ready? 1, 461. For the Y's, 1, 575, negative 1. For the Z's, 1, 650, negative 1. I'm augmented with 20 105, and 0. This is my augmented matrix. It is a 3 by 4. I'm going to my calculator. I'm going to hit, let me make sure I entered this right. 111, 460, 575, 650, 20, 105, 0, 1, and 1, 1. Okay, cool. So this is our matrix. Now, I'm going to go to my matrix. I'm going to hit second matrix. I'm going to edit. I'm going to write over matrix A, which I just got through doing. So I still want it to be a 3 by 4. So make it a 3 by 4, and then go through and enter 1, 1, 1, 20. 1, enter, 1, enter, 1, enter, 20, enter. And then feed in 460, 4.6, enter. 5.75, enter. 6.5, enter. 105, enter. 1, oops, that's not right. -1, -1, 0. Second, quit. Now I'm going to call this matrix up to make sure I entered everything correctly. So the second matrix, I'm going to select A because that's where I put it. You didn't have to put it in A again. You could put it somewhere else. And so if you look at this, I'm going to see if I like it. Yeah, if you look, this is what it looks like. And so I can see the first 3 columns, but not the fourth. So I'm going to toggle to the right. So then I can see my last 2 columns, make sure I'm happy with it. And I am. So now I'm going to do the calculation. Hit second quit to get out of the entering mode. Go to second matrix. Toggle to the right to math. Go down till you hit RREF. Hit enter. And then tell it what matrix you want to do the reduced row echelon form. Second matrix. I'm going to put in A because that's where I put all my information. And when I do that, this is what I get. My nice little reduced row echelon form. And this tells me that X, what is X? Yeah, X is 10. So this, sometimes I might ask for the reduced row echelon form. So this is what you should write if I ask for that. 10, 8, 2. So that's what the reduced row echelon form is. 1's on the diagonal, 0's everywhere else. And so if you had to write a sentence, you might say, okay, 10 pounds of the 460T should be used. 8 pounds of the 575T and 2 pounds of the 650 should be used. There you go. All right, cool.